Let's talk about Chapter 15. Chapter 15 deals with correlational analyses. So we're going to talk about what different correlations mean, how to interpret correlations, and how to conduct a correlational hypothesis test, particularly using SPSS. So a correlation it's really just a measurement of a relationship between two variables. So correlations in general look to see if two different variables are related to each other. And so normally we're going to identify these two variables as X and Y. And you can think about those two variables in a graph format. So we're going to be dealing with a lot of graphs in this chapter, in that our X will be one of our variables and our Y will be the other variable. And we're going to look at the relationships between these two different variables in a graphical sort of way. So lots of graphs to look at in this lecture. So be sure to use the printed off lecture notes. Those will be really helpful for you. Well, they're not printed off, I guess. They're online. But the lecture notes will be especially helpful for this chapter because I've included all of the graphs that are in this lecture. So let's talk a little bit more about correlations, and specifically the Pearson correlation is the most common correlation, and it's going to be the main one that we're focusing on in this chapter. So we'll discuss this a little bit more in a bit, but the Pearson correlation is primarily used to identify the relationship between two variables that are both measured on a interval or ratio sort of scale. So again, that would be essentially just variables that are measured with numbers. So if your variable was measured with numbers, you can use the Pearson correlation to examine the relationship between that variable and another variable that is also numerical. So the Pearson correlation is going to give us a couple of bits of information contained within its measurement. So Pearson correlation is going to tell us, first of all, what direction the relationship is between the two variables. So the direction could be either positive or negative. So I'm going to talk about each of these two different directions on their own first. So anytime you have a correlation, it's going to be either a positive or negative number. So if it's a positive number, then it's a positive correlation. If it's a negative number, then it's a negative correlation. Pretty straightforward. So if your number is positive, so there's no negative sign in front of it, basically. If your number is positive, then that's a positive correlation. And here's what a positive correlation looks like. So in this example, we have the number of hours studying as our X variable on that horizontal axis. So this is always going to be called our x-axis. So again, our correlations are looking at the relationship between two variables. So one of the variables here is going to be the number of hours you spend studying. And then our y variable, the second variable, is going to be here on the y-axis. And so we're looking at the relationship between our studying and your exam grades. And in general, just the way that graphs are set up is we always have 0 is at this crevice here. And so smaller numbers are closer to that crevice. And then the further you get along this line, the bigger the numbers are. Same thing goes for the y-axis. So down here we have the smaller numbers. And then as we go up, it's larger numbers. So each of these different yellow dots represent a different student. Let's say I made up all these data, but let's imagine that each of those yellow dots represents a student. So here we have one student that studied not a lot, and they also didn't get a very high exam score. We have some students here in the middle. They studied about an average amount and got a slightly lower than average exam score. Then we see up here this student who studied quite a lot, so they're in the really high part of the hour studying. They also had a really high exam grade. So if we were to get a line to represent these data, like the average kind of trend of these data, in general, the trend of these data kind of form this line that slants up. And so this is what a positive correlation looks like, is where the line or the direction of the data, it slants in this upward kind of direction. And so in general, when we have a positive correlation, what that means is a high score on one variable is going to be associated with a high score on the other variable. So here we have, those students that spent a lot of time studying. So students that are up towards this higher end of X also are going to have a higher value for Y. So a positive correlation means a high score on one, you have a high score on the other. At the same time, though, if you have a low score on one, you're also going to have a low score on the other. So those students that didn't spend very much time studying are also going to have a low exam score. So both of those two things exist in a positive correlation. Another way to refer to the positive correlation is to say it's a direct correlation, so that your values on one are directly corresponding to your values on the other. So you have a high score on one, you have a high score on the other. You have a low score on one, you have a low score on the other. So this is what a positive correlation looks like. So now let's talk about the other possibility, which would be a negative correlation. So a negative correlation looks very different in terms of how the data are distributed. So in this example of a negative correlation, our X variable is going to be the number of hours of TV you watch, and then our Y variable, the variable on this Y-axis, is going to be your exam grade. So here we'll see a very different trend in our data set, wherein a student that spent very few hours, so a student down here on the small end of the hours of TV watched, that student actually got a pretty high exam grade. So low hours of TV watched were associated with a high exam grade. And then over here we have our students who watched a ton of TV, so those students right above that really high value for hours of TV watched, those two students have pretty low exam grades. So that's an example of what a negative correlation looks like. You see that these data points are trending in this kind of general downward sloping direction. So that's a negative correlation there. And what a negative correlation means is that if you have a high score on one variable, so let's say our high score on X, so you spend a lot of time watching TV, that's associated with a low score on Y. So here we have a lot of TV being watched is associated with a very low exam score. Also, at the same time, if you have a low score on your X, so if you don't spend a lot of time watching TV, that's associated with a high score on Y. So you have a higher exam grade if you haven't watched a lot of TV. So sometimes this is also called an inverse relationship, which just refers to the fact of if you have, one thing that's high, you have the opposite or the inverse sort of relationship or value on the other. So a high on one is always going to be related to a low value on the other. So that's an inverse relationship or negative relationship. So another bit of information that's contained within a correlation is going to tell you about the strength of the relationship. So the strength of the relationship is the actual number involved in the correlation. So these data are an example of a correlation of +1. So 1 is the highest possible number that you could ever have for a correlation. And a value of 1 for your correlation indicates a perfect fit in terms of the actual correlation. What that means is that every single one of your data points, so all of the people in your study, are perfectly fitting on this line. So an example of a variable that might have a perfect positive correlation would be the number of steps that you take and the amount of distance that you travel. So presumably, with each step you take, you're traveling at about the same distance. So with each additional step you're taking, you're having the exact an exact same change in the amount of distance that you're traveling. So that's an example of a perfect positive correlation. You see that all of those data points are falling on that straight line of your positive correlation. Here's an example of a perfect negative correlation. So perfect negative correlation would have this correlational value of, again, all that's changed here is the sign. So it's -1 would be a perfect negative correlation. And you'll see there that all of our data points are falling exactly on that line as well. So an example of a variable that might have a perfect negative correlation would be the speed in which you're traveling, and then the time in which it will take you to reach your destination. So the slower you're traveling, the more time it's going to take you. But the faster you're going in miles per hour, the less time it's going to take you. So with each additional mile per hour increase, you should see an exact decrease in the amount of time involved to get to your destination. So that's a perfect negative correlation. Also, your correlation could be 0. So if you have a correlation of 0, that means there is no correlation at all. So no correlation, meaning these two variables aren't related at all. So for example, the number of steps you take in a day probably doesn't matter at all in determining what your GPA is. So you'll see some students that don't take a lot of steps per day, have an average to low GPA, but there are also some students that don't take many steps per day that have a high GPA. These two variables aren't related at all, so there's no correlation. So no correlation in general. There's no trend in terms of like an upward slant or a downward slant. It's just not predicted. One value doesn't predict the other at all. In general, the bigger the number of your correlation, so the closer your number is to 1, and that could be in either direction. So the further away your number is from 0, the closer it is to 1, the stronger your relationship is. So in general, our correlations are going to be ranging from -1 to +1. And again, the further away our values are getting from 0, the stronger the relationship is. So these would be stronger negative relationships. These are stronger positive relationships.